Okay, so we are presenting ELSA, a style aligned dataset for emotional intelligent language generation. This is the outline of our presentation. We are going to introduce what the problem is, what work has been previously done, why we solved this problem, how did we do it, what are the applications, and what are the conclusions for the. So the motivation is our language is highly complex. We deal with a lot of emotions, but apparently there is no single data set that is emotionally rich, that is rich in emotions. At the same time, it has style variants. For example, in 2018, there came dair-ai, which has 6 broad emotion categories, but that's not enough. Like we know, 6 emotions are very basic. Uh, then in 2021, there came GoEmotions. This is from Google. They came up with 27 emotions, but there is no stylistic variations in those texts. They just script read it and labeled the data set. So that's where we come in. We figure out that this is the problem, that existing data sets fail to capture the emotions as well as the stylistic variations of those emotions. That's why we create ELSA dataset, which bridges the gap between fine-grained taxonomy of emotions with their stylistic variations. For example, the way we express emotions in conversational topics is different than how we perceive emotions in poetry or in a narrative storytelling. So a little bit of history of how emotions dataset have evolved over the period of time. Early in the day, back in the 90s, there were lexicon-based methods for emotion dataset. Word and affect dataset is pretty famous. Then there was a distant supervision, which was large scale but pretty noisy. They just scraped Twitter and basically labeled the sentiments on the dataset. Then came the other data sets that I mentioned, the GoEmotions data set. And with advent of LLMs, there is LLM, which is actually an LLM, not a data set, but it's controlled emotion text generation. Our dataset creation pipeline is fairly simple. We take the emotions dataset of dair-ai, which has only 6 course emotions: the sadness, anger, love, surprise, fear, and joy. We map these emotions onto GoEmotions fine-grained categories. By map, we mean we run their model, GoEmotions model, and classify each of the sentence in one of the 27 categories that GoEmotion maps. And then we add stylistic augmentation, that once we know what emotion this is according to GoEmotions, we use LLM to generate variations of that same sentence. We ask LLM to generate, what if this sentence was said in a formal sentence, formal setting, how would it sound? What if there is poem around this sentence, how would it sound, etc. For quality control, we obviously do the GoEmotions classifier, as well as we have a bunch of evaluation metrics down there, which I'll explain in a bit. But before that, I want to explain what these 27 emotions are about. For example, when we talk about sadness, sadness falls into sadness or grief or remorse. Love falls into love and admiration and caring. Joy falls into joy, excitement, pride, gratitude, amusement, etc. For evaluating our data set, we measure it heavily. We want our data set to be statistically significant and accurate. So we calculate the embedding variance, which should be lower. Then we calculate the average emotion distance from one emotion to the other emotion, so that in latent space, all emotions are distinct groups. Then we calculate the lexical diversity. Then we also calculate the self-clue that text is not similar to itself. Then we also calculate the Flesch-Kincaid score, which gives us a readability that generated text is not gibberish. And finally, we calculate the perplexity as well. The results are in the table. As you can see, the embedding variance is low across the board. Emotion distance is fairly large, the mean and median, which is at least half. Average readability is 57 to 58 if we consider median. By the way, the average readability of a graduate student in the United States is 4D. So there's more than average graduate students' readability. Then texts are distinct. Blue score is near zero. Perplexity is more than 60, mean and median. So I just explained these scores to you. Uh, my partner will talk about the use cases here. Vishal, you can go ahead.
Sure. Am I audible? Okay. So one primary research use cases are fine-tuning for emotionally nuanced transfer. As we know, LLM use is exploding at this time. There are numerous use cases, not just in form of writing books, but for the law as well. And how you structure your sentence, how you structure your story makes a lot of difference. This is this research is also heavily useful for computational storytelling and generating stories, which again feeds into larger law, medicine, book generation, technical, and topic-wise, emotional, topic-wise story generation. Primarily prompt engineering and um, how people are writing these prompts make a lot of difference into output of LLM. There is a lot to be said around the latent computation and latent abilities of LLM, and I think this is the foundational research that helps into building the context-aware emotional explanation of the stories and getting output from LLM. Another use case that we have seen is around conversational AI and chatbot. So you have this almost a lot of every sector is now already embedded into using chatbots. So how say a dentist office uses chatbot is way different than how, for example, a law office would use chatbot. And similarly for customer support and other use cases, creating empathetic conversation for e-commerce and other stores is really a useful use case. Another thing that we have seen this can be used is for primarily for social science research and understanding and doing research around language and language specifics. A lot of research around psychology can also be based on this specific use case. Next slide, please. So ELSA creates a novel data set. The data set that we have published it online. You all can play with it and you can build model out of it. We have done validation. We have computed metrics, and that does represent some diversity and a step ahead of GoEmotions data set from Google. Another thing that we have seen is our research. It's kind of really useful for understanding how language is used and how benchmarks are established as we try to understand and get more out of LLMs. Back to you, Sagar.
Okay. So by no means this is be all and done all kind of data set. We haven't tackled emotions entirely. Uh, there are future works to be done if anybody in the community is going to be interested in this direction. It's bias mitigation. Our currently generated text is heavily biased by how LLM generates the text. Then we would want to see more fluency. For example, the more poetic and complex sentence structure is currently lacking. We would want to expand the coverage to other languages as well, so that we could have multilingual emotional data set. And finally, we want to integrate multimodality into our future work. This dataset is publicly available on Hugging Face datasets Joyspace AI. You can pretty much access the dataset. These are few of the very important references from the paper that we just presented, and we are open to any questions that you might have.